Have you ever been deep into coding only to hit a wall with a frustrating error? It can be incredibly annoying, right? If you're facing issues with generating a segmentation fault from a custom Syscall, you're in the right place. Today, we're going to tackle this problem together. I completely understand how perplexing it can be when your code doesn't behave as expected. You're not alone in this struggle. Many developers encounter similar issues when working with system calls and memory access. Let's dive into the specific question at hand. One user asked, how can I get my custom syscall to generate a segmentation fault or SIGBUS error when using copy to user? This is a common scenario when dealing with user space and kernel space interactions. Sound familiar? Let's explore this together. So what's happening here? When you call copy to user, it attempts to copy data from kernel space to user space. If the memory address is invalid, you want it to behave as if the user space is trying to access that memory, resulting in a segmentation fault or SIGBUS. Understanding this interaction is crucial for troubleshooting. And stick around. At the end of this video, I'll share a valuable tip that can help you avoid these issues in the future. To generate a segmentation fault or a bus error from a custom syscall, the user should first ensure that they are correctly using the copy to user function. This function is designed to copy data from kernel space to user space. Next, the user should check the return value of the copy to user function. If this function fails, it will return a non-zero value, indicating that the copy operation was unsuccessful. If the copy to user function fails, the user can simulate a segmentation fault by deliberately accessing an invalid memory address. This can be done by using a pointer that points to an invalid location. Finally, the user should handle the error appropriately. If the copy to user fails, they can return an error code or trigger a kernel panic to simulate the behavior of a segmentation fault. Fun fact, did you know that segmentation faults are named after the concept of memory segmentation? It's a fascinating topic that goes back to the early days of computing. Now let's look at the answers provided by other users. This user explains that generally, you can't generate a segmentation fault from a syscall without rewriting the kernel. The kernel uses safe methods like copy from user and copy to user, which return an error code, typically -e fault, when they fail. This error is then adjusted by libc to set error no for user space. However, if you're writing your own syscall, you can trigger a signal easily. The user suggests using the send siginfo function from the kernel's signal handling code to achieve this. Here's that valuable tip I promised. Always validate memory addresses before accessing them in your syscalls. This simple practice can save you a lot of headaches down the line. And there you have it. You now have the tools to generate segmentation faults or SIGBUS errors from your custom syscall. Remember, validating memory is key to smooth coding. If you found this video helpful, hit that subscribe button for more tips, and don't miss our next video where we dive deeper into syscall debugging.